The spectrum came back flat. TRAPPIST-1b should have shown a trace of gas-bending starlight as it passed through an atmosphere. JWST found almost nothing. Then TRAPPIST-1c came back the same way. Two rocky worlds, close to a cool red star, both look like bare rock. That doesn't tell us anything definite about TRAPPIST-1e. It orbits farther out, inside the zone where liquid water should be possible, with a density close to Earth's. It's the most cited habitable zone rocky exoplanet we can actually study with a working telescope. But B and C just failed a test. E hasn't taken yet, and the reason matters for the whole system. Red dwarfs like TRAPPIST-1 don't start out calm. For their first billion years, they flare constantly, pouring out extreme ultraviolet radiation far beyond what their visible light suggests. A planet sitting in the temperate zone today wasn't always temperate in practice. It sat in the blast radius of a young, violent star. If that radiation stripped the inner planet's atmospheres, E absorbed the same exposure. The zone is a location. The flaring was a history. Those aren't the same thing. The boring explanation for airless B and C, they were always going to lose their atmospheres, orbiting close enough that even a calm star would eventually erode them through slow thermal escape. No drama required. It fits data from other compact red dwarf systems with similarly stripped inner planets. The crack in that explanation is timing. Thermal escape alone, from a star past its violent youth, is often too slow to fully strip a planet within the system's age. The pre-main sequence flaring phase does the damage faster, while the star is still young and extreme. If that phase did the stripping, it didn't stop at the innermost planet. The UV flux reached E's orbit too, just weaker. That's the second clue. The loss mechanism doesn't respect the habitable zone boundary. The line between too hot for water and temperate enough for oceans has nothing to do with how much atmosphere-stripping radiation a planet absorbed in its first 100 million years. A planet can sit at the perfect temperature and still have taken a heavy dose of UV before that temperature ever mattered. If TRAPPIST-1e kept any atmosphere, it either survived the radiation or refilled afterward. Three routes could explain that. Volcanic outgassing could resupply gas from the interior, the way early Earth and Venus did. Late delivery from icy impactors could bring water and carbon compounds after the worst flaring ended. A strong magnetic field could deflect stellar particles the way Earth's field deflects the solar wind. Each is physically reasonable. None is guaranteed, because none has been directly measured. The less comfortable explanation is this. Close-in planets around active red dwarfs may almost never keep their original atmospheres, and any atmosphere JWST finds on E could be secondary, built after formation, rather than inherited from it. That would make habitable zone a weaker predictor of habitability than the term suggests. The observational limit is real. JWST's transit spectroscopy of TRAPPIST-1e requires stacking multiple transits to pull a faint signal out of stellar noise, since the star is active enough to contaminate data with its own spots and flares. A single transit isn't enough. Current campaigns are still narrowing the uncertainty without closing it. The future test is specific. JWST is watching for water vapor, carbon dioxide, and methane in TRAPPIST-1e's spectrum across upcoming cycles. A clean detection wouldn't prove biology. It would prove the planet survived its star. A null result wouldn't prove the planet is dead rock either. It would prove the atmosphere loss story reached further than expected, and that surviving took more than just distance from the flare. Either answer teaches us something the habitable zone label can't. The zone measures temperature. It says nothing about the sequence of events a planet lived through to still have air worth measuring. If this is the kind of cosmic mystery worth following, subscribe. The next transit cycle may finally answer it. The honest question is which side deserves the benefit of the doubt. The boring answer, where close-in rocky planets around young red dwarfs are simply stripped and stay stripped, or the hopeful one, where volcanism, impacts, or magnetic shielding rebuild what radiation destroyed. TRAPPIST-1e sits exactly on that line, and no one is choosing sides yet. The habitable zone was never a promise. It was a coordinate. What happened there, over 100 million violent years, is the part JWST is still reading.